Because of the observation by Edwin Hubble, we know that the universe is expanding. Because of Fred Hoyle, we now call it the Big Bang. The universe was once concentrated into a point with zero volume, but scientists call it singularity, and exploded. The universe was born in primordial fireball about 14 billion years ago. If we look to the cosmos in any directions, we find the galaxies are generally moving away from us, and the farther away they are, the faster they move. In 1964, American physicians Robert Wilson and Arno Penzias discovered a hiss in the radio spectrum that was identified to be nothing less than the signature of the fireball of the Big Bang. The temperature of the Big Bang were once unfathomably high, emitting gamma waves from sources far hotter than create visible light. The universe has since expanded and cooled all the way down to 2.7 kelvins. The cosmic microwave background, or CMB, is the cold remnant of the first light that could ever travel freely throughout the universe. This fossil radiation, the furthest that any telescope can see, was released soon after the Big Bang. The hydrogen and helium nucleosynthesis is the process of the creation of a new element or an element. The Planck era is divided as the time when the universe was the size of the Planck length, 10 to 33 cms, and less, and the universe age was 10 to 43 seconds, the Planck time and less. It is the earliest epoch we identify after the Big Bang. The Planck temperature is at the end of the epoch was about 1032 degrees Kelvin. A singularity is a point in space where there is a mass with infinite density. This would lead to a spacetime with an infinite curvature. Singularities are predicted to exist in black holes by Einstein's theory of general relativity. Relatively. God era. The God era is when three of the four fundamental forces are combined, but gravity has become distinct. The God era lasted from 10 raised to negative 43 seconds to 10 raised to negative 38 seconds. Near the end of this era, grand unified theories predict that the universe cooled to the point that the nuclear strong force began to freeze out, leaving three fundamental forces, which is the gravity, the strong force, and the still combined electroweak force. The electroweak era, as a space expanded more rapidly than the speed of light. Extremely energetic interactions created elementary particles such as photons, gluons, and quarks. The era ended with the separation of electromagnetism from the weak force. During this era, particles continually were created and destroyed until by 0.0011 millisecond, the universe had expanded and cooled for enough to 1012 kelvins that creation and destruction of this kind ended. For some reason, the universe created slightly more matter particles than antimatter particles. Era of nuclei. Nuclear reactions could occur until about 3 minutes after the Big Bang. At this point, the temperature became too low for them to continue. However, the temperature remained high enough to keep all the atoms ionized, electrons free from the nuclei, until about 300,000 to 500,000 years past the beginning. Matter era. Matter gradually began to coagulate into atoms and eventually into clusters of atoms. From the start of the matter era, matter dominated radiation, and it has dominated radiation ever since, successively forming galaxies, stars, planets, and life.